Hello and welcome. My name is Natalie Smith and I am your session moderator. If you have any questions during the session, there will be time for questions at the end of the presentation. Please submit your questions in the Q&A widget. The slide pack is not downloadable, but the session will be recorded and will be available later today on demand. I would like to introduce you to Richard Morgan, Principal Consulting, and Alessandro Ravignolo, Principal Consulting, who will be presenting on rural connectivity, new opportunities for investors. Over to you.
Thank you, Natalie. So good afternoon, everybody. Alessandro and I are both principals in the London office, and a lot of our work is focused on transaction support. So we're seeing a great deal of investment in digital infrastructure, which is gathering pace across Europe, and we're seeing some intense competition among investors, in particular for the major asset classes of towers, fiber, and data centers. Today, we'll be talking about some of the considerations around extending connectivity to rural areas, where different models are often required. These models can create opportunities for investors with different costs of capital, including some which may have not been as good a fit for traditional digital infrastructure assets. So today's presentation has a focus on Europe, but the trends we discuss are largely applicable to other regions as well. So we'll start by providing some context around rural connectivity. So delivering connectivity infrastructure to rural areas is more expensive. And while urban areas are seeing investment in fiber and 5G coverage, many rural areas are being left behind. So this digital divide has been a focus of policymakers for some time, with strong demand from rural communities. But COVID-19 and the recent lockdowns have brought this into focus. So all of you joining this online event will, of course, be aware of how essential good broadband has become for many people to work from home, buy food online, or keep in touch with family and friends. Secondly, the cost of deploying full fiber can increase significantly as networks extend to more remote rural areas. So even with government subsidies, it isn't going to be viable to reach 100% of rural premises across Europe. And other technologies such as fixed wireless access and satellite broadband will need to play a role in most markets. There are a large number of dedicated FWA players, fixed wireless access, across Europe, focusing on this rural opportunity. And we're also seeing a growing number of players pursuing hybrid strategies, deploying both fiber and FWA technologies. Alessandro will then talk about some of the new approaches being taken by mobile operators to support extension of coverage to rural areas, such as neutral host models. He'll also talk a bit more about what all of this means for investors in the digital infrastructure sector. So first, looking at demand. Household penetration of broadband is increasing with more and more people coming online each year, and also the average user is consuming more data. So on the chart here, you'll see that average usage in Western Europe has increased by more than 3 times in the last 5 years since 2015, and this is forecast to more than double again over the next 5 years. So this usage does vary across markets, and we're seeing particularly high usage in the UK, where OTT video streaming is very popular on platforms such as BBC iPlayer and Netflix. And these growth trends have been accelerated by COVID and the resulting lockdowns. So, for example, BT in the UK reported in April, when the UK went into lockdown, that its full fibre subscribers saw their usage actually double during that month, getting close to 1 terabyte per user per month. Much of this effect will be temporary, but there's still strong underlying growth in the market, and this is driving demand for high-speed broadband infrastructure. So in response to this demand, incumbents and alternative network operators are investing heavily in broadband infrastructure, but there's still a long way to go in Europe, as these charts show. So the chart on the left shows coverage of networks providing 30 megabits per second speeds, which is aligned with the European Commission's previous 2020 targets. And while this coverage is high across most of Europe, there are still millions of premises which are stuck at much slower broadband speeds. The focus across Europe is now turning to fiber to the premises, or FTTP. And on the right-hand side, we can see this varies quite considerably. So the UK and Germany have among the lowest levels of FTTP coverage, This is largely due to the incumbents in those countries focusing their investments on fibre to the cabinet, while other markets, the operators were faster to move to full fibre. We can see France has seen some of the steepest growth in recent years, particularly driven by government intervention programs in rural areas. And then other countries like Spain and Norway already have quite high fibre coverage, Spain at over 90% of premises. But reaching the last few percent of premises in rural areas becomes increasingly challenging. So in terms of the policy situation, policymakers across Europe are very conscious of the socio-economic benefits of broadband networks, and they've set targets aiming to ensure that rural areas aren't left behind. So policy is generally not going as far as targeting ubiquitous full fibre coverage, and we do see some interesting differences between countries. So at the EU level, the European Commission has set targets for 2025 as part of its European Gigabit Society strategy. This aims to achieve universal coverage of 100 megabits per second by 2025, which should be upgradable to 1 gigabit per second in the long term. So this is a technology neutral target that leaves the door open to the use of fixed wireless solutions, recognizing that full fibre may not be viable everywhere. National governments across Europe have adopted varying targets within this 2025 timeframe. Germany and UK have already mentioned are behind on full fibre deployment compared to other European countries, and the governments have set relatively vague targets without firm commitment to 2025. Notably, the UK government had previously targeted 100% coverage of gigabit-capable networks within this timeframe. This is widely seen as unrealistic, and it's since watered down to a fairly non-committal target to go as far as we possibly can by 2025. France has set a more ambitious target to extend full fibre to subscribers throughout the country. Notably, that the current regional intervention programs are not designed to achieve this 100% full fibre coverage, and there's not yet funding in place to achieve this policy, but it is clearly more ambitious than the targets we're seeing in some other markets. Spain already has some of the highest fibre coverage in Europe, but it recognises it will be challenging to reach the most rural areas with fibre. And its targets for 2025 are focused on ensuring 100 megabits per second coverage to all premises. And this will likely include some fixed wireless solutions for the more remote rural areas. Fibre to the premises is the target of most broadband infrastructure investment we're seeing at the moment, as it's seen as the best performing and most future-proof technology option. But there is, however, a role for fixed wireless access, which can be a more appropriate solution in some areas. So this slide shows some of the relative benefits of each of these two technologies, some of which Rupert touched on in his presentation yesterday. But fibre on the left-hand side, firstly, it has clear advantages in terms of peak speed and bandwidth. Most FTTP networks today have speeds of up to 1 gigabit per second, but we're seeing the launch of XGS-PON networks with 10 gigabits per second speeds services already. Also, uplink performance is a key advantage of fibre, which can offer symmetric services with even download and upload speeds. And these upload speeds are becoming more important with people working from home increasingly, using cloud services or video conferencing, for example. Fibre also has advantages in terms of reliability and quality of service. It can offer more consistent speeds, whereas wireless networks are inherently more subject to congestion as users share the bandwidth within a cell. Fibre is less prone to faults and outages, whereas wireless networks can be impacted by something as simple as a tree growing and obscuring line of sight to a household. Fibre also has long asset lifetimes. Once fibre is in the ground, the passive infrastructure should last for well over 20 years, compared to wireless equipment, which may need to be replaced or upgraded every 5 to 7 years. And then the active equipment in fibre networks will also be further upgradable to offer faster speeds in future, what should be a relatively low cost, and is therefore seen as a more future-proof infrastructure. And finally, fibre also has advantages in terms of OpEx efficiency. I've already mentioned that these networks typically experience fewer faults and therefore have lower maintenance requirements, and fibre networks also use less power than wireless or copper networks. So that all being said, the cost of fibre can be prohibitive in rural areas. And one of the key advantages of FWA is that it can have lower upfront capex. So this CapEx level is highly variable based on the type of technology and the deployment approach. And it's also necessary to consider the total cost of ownership due to fixed wireless equipment having shorter asset lifetimes and typically higher operating costs. Other advantages of FWA include network deployments can be much more rapid to deploy. It's often can you make use of existing infrastructure such as mobile towers and existing backhaul. And a single site, when it goes live, can provide coverage to a potentially large number of premises. FWA also has relatively simple installation. So rural fixed wireless deployments will typically involve external antennas on users' houses. And this can be self-installed, but will usually require an engineer visit. This is a much more simple task than installing a physical fiber connection for the final drop, especially considering this can be quite long distances for some rural premises. So generally, the main opportunity for FWA in rural areas will be where the cost of fiber becomes prohibitive. And despite having some downsides in terms of performance, these wireless networks can provide a more cost-effective solution. So to illustrate the challenge of deploying fiber to rural areas, Norway is a good market to look at due to its mountainous terrain and sparse rural population, which makes it particularly challenging to deploy infrastructure. So this chart shows some analysis done by colleagues in our Oslo office, which was done on behalf of the Norwegian government. And it's based on a complex network dimensioning algorithm that accounts for the location of every premises across Norway and what infrastructure would be required to serve them. So despite having a large rural share of the population, Norway currently has over 70% full fiber coverage. This is over 80% gigabit capable network coverage when you include cable networks. And this model has been used to estimate the cost of reaching the last 14% of rural premises using either fiber or fixed wireless networks. So you can see, firstly, with the pink line, that at the edge of current networks, full fiber costs less than $2,000 per customer. This is including both the cost to pass premises and also connection capex for connecting these customers. But as you extend towards more rural areas of the country, this cost goes up steeply. And it also rises exponentially for the last 1 or 2%, where long fiber route distances are required for each premises. The FWA cost estimates, shown in blue, are largely on the basis of assuming that existing mobile networks in rural areas are upgraded to support 5G FWA services. So for most of these rural areas, the cost of deploying 5G FWA is in the hundreds of dollars per premises connected, rather than the thousands of dollars needed to connect these same premises with fiber. Even with wireless networks, though, once you get to the most remote rural premises, the cost per household rises dramatically, as you'd need to deploy a 5G site to serve just a handful of premises. And it's these most remote rural areas where satellite broadband is likely to play a role. Satellite is often seen as a last resort due to latency and the high cost of bandwidth. It's worth noting that the performance and pricing of satellite services is expected to improve as a result of new satellites and constellations that are being launched in the coming years. So it seems clear that FWA will continue to play a role in rural broadband, and there are a range of players following different business models. Across Europe, there are a large number of dedicated FWA players, often with small regional networks, and many of these have evolved from community-led solutions, which have grown in scale over time. Many of these networks can be seen as interim solutions, so they're currently providing connectivity in areas where the existing fixed broadband is poor, so these FWA services are able to compete effectively, but where fiber build is expected in the longer term, often with the help of subsidies. So many FWA players recognize this threat, and they're actually choosing to overbuild their own footprints with fiber, or in some cases following hybrid strategies with both fiber and FWA serving different areas or purposes. Some players are choosing to deploy FWA first as a means to drive take-up in a certain area. And then once they have this massive subscribers on the network, this can de-risk the fiber investment, or improve their position to benefit from government subsidies. FWA may also be limited to an interim solution based on government policy. So we've already mentioned the example of France, where FWA is being deployed as part of some of the regional intervention projects in rural areas, but the spectrum being used is being granted on a temporary basis on the understanding that full fibre will be deployed in the longer term, being consistent with the government's national targets. As shown in the second block, we're also seeing a trend for mobile operators to launch FWA services as a way of monetizing spare capacity on their mobile networks. So particularly following the launch of 5G networks, we've seen more operators promoting FWA as a way to fill up these relatively empty networks. In some cases, services are made available on a targeted basis where the operators know their network has sufficient capacity. There are limits on this approach, as FWA subscribers have much heavier usage than mobile users, typically by around 20 to 30 times in Europe. And for operators with revenues that are driven by mobile customers, they'll be reluctant to risk network congestion for a relatively small number of fixed wireless customers. And we're generally not seeing MNOs deploying infrastructure with FWA in mind in most cases. The third model shown here is applicable to converged players, which are in some cases deploying hybrid customer premises equipment that will work with both their fixed and mobile networks. This is particularly popular in Germany and Austria, where 4G or 5G networks are being used to provide a performance boost to slower ADSL or VDSL lines, or to act as a backup to improve reliability. Telia in Finland is offering hybrid CPEs, but it's motivated more by an effort to promote offload of traffic from its 4G network, as a lot of customers rely heavily on mobile broadband in Finland. And finally, there are players deploying FWA infrastructure as a long-term solution. This is typically in areas where there's not sufficient density for fibre to be viable, and where national subsidy regimes are not expected to fund fibre. So some of the hybrid players will overbuild parts of their own FWA coverage with fibre, where they have clusters of premises they can address, but will still keep FWA networks to serve other parts of their footprint. And these business models are all linked to the technology being used. So many dedicated FWA players today are using Wi-Fi or WiMAX-based equipment, and this is based on unlicensed or lightly licensed spectrum. This is a very low-cost approach, meaning they can deploy rural sites serving a small number of premises. It also has limitations in terms of performance. So these Wi-Fi networks typically offer between 10 and 100 megabits per second. It's generally not consistent with targets for most policymakers, and won't be well positioned to compete effectively against fibre if the networks are overbuilt in future. So some MNOs are offering FWA over both 4G and 5G networks, but it's notable that it will take some time for 5G network coverage to reach rural areas. And we are seeing some of the dedicated FWA players looking to transition to 5G technology to enable gigabit-capable speeds in future. But the higher cost and complexity of 5G means that it's a dramatic change in the business model from the low-cost Wi-Fi solutions, and it's not going to be suited to all players. As mentioned, many of the dedicated FWA players across Europe are transitioning towards hybrid models and are also deploying fibre infrastructure. This map shows some of the major wireless operators in the UK. It's just a selection, as there are over 150 active players in the market, but many of these are very small scale. Those marked in green on the right-hand side are those which have either started deploying fibre or have announced fibre plans. And we're seeing similar trends towards hybrid models in other markets across Europe. So as these fixed wireless players start deploying fibre as well, it requires a change towards a higher capex model, which is creating opportunities for investors as these players look to raise capital. And these hybrid networks may suit a different type of investor to those that have been targeting pure fibre players. Also, given the fragmentation of the market with many small regional players across many countries in Europe, we're also seeing consolidation taking place, and there'll be a potential opportunity for bolt-on acquisitions. So with that, I'll now hand over to Alessandro, who will talk more about the considerations for mobile infrastructure in rural areas.
Thank you very much, Richard. So moving to the next slide, the policymakers' agenda to improve connectivity in rural area does not stop to fixed networks, and actually extend also to mobile networks, which are also an important part of the policies. However, we must note that there is a dramatically different starting point between fixed and mobile. In fact, when we talk about population coverage or mobile population coverage, you can appreciate that the coverage is most ubiquitous in Europe, because most of the markets report 99.9% coverage of inhabitants. However, when we look at the picture, right, of the distribution of mobile networks across the geography, you see that there are still large portion of the land mass that is not covered, right? And Italy in the slide actually provide a nice example. You see there the distribution of the point of presence of the major operator in Italy, and there are still gaps. These gaps are lately coming to the focus of policymakers and regulators that make part of the agenda to try to reduce them as much as possible. And this typically takes the form of a coverage obligation included in spectrum licenses. So most of the latest 5G spectrum auction included obligations that forced operator to cover the main transportation access, typically with a certain minimum download speed, as well as extending the service to remote municipality or even scattered villages. Sometimes also provide a very specific list of areas that needs to be covered. The implication is also that operators typically do not receive subsidy for this additional deployment, which is so a very difficult situation than what we see on the fixed broadband side of things, where there is an increasing relevance, an increasing role of national European subsidies to support fiber deployment. So operators when deploy towers really need, in rural areas, really need to start try to recover the cost with their own revenue stream, their own cash flow coming from consumer mobile services, but also increasingly B2B connectivity services, as some of our research colleagues talked earlier about new IoT industrial use cases that require ubiquitous connectivity and very low latency connectivities in rural areas. So recovering the cost of deployment in rural areas is not easy, and because the commercial case of deploying in areas where mobile networks are not already present today present challenges. We need to remember that so operators and infracos operates in a context of an ARPU that has degraded quite a lot in the past few years. We've seen sign of stabilization lately, but we have seen strong decline in Europe, but also in other regions. If you link the ARPU decline also to the fact that when deploying in remote areas, you see a decreasing number of inhabitants that are addressed from incremental towers. You could understand that the business case of this additional deployment turned quickly negative. Just to give an idea, urban deployment in Europe see something like 1,000 inhabitants per cell, whereas even now today in certain markets, most rural sites could only have 300-400 inhabitants that are covered by that infrastructure. When we look at remote areas, we might talk about 100-200 inhabitants per site, which means relatively limited amount of additional revenues, right? So if you take just an example, we assume a 15-20 euro of ARPU per month. For 200 inhabitants, you will get 3,000 euro per month, 400,000 euro basically over 10 years. And 400,000, this is sounds a big number, but in reality is more or less the total cost of ownership over a 10-year period of a mobile site, including the cost of deployment, but also operation and maintenance. So operators will hardly make any money at all, right, with traditional deployment approaches. So it becomes quite natural that operators start looking more and more into a way to reduce costs in order to reduce the total cost of ownership of rural infrastructure, in order to basically make positive returns from these investments as much as possible. Traditionally, this was done through passive sharing, which effectively means sharing the real estate part of the site, plus also the mast and the passive equipment in general, right, on the site. However, when we're talking about rural deployment, this gives material savings, but what we estimate around 20%, or assuming a 20-year total cost of ownership. But when we're talking about deployment in very rural areas, this is not sufficient. So it's quite unsurprising, it's definitely unsurprising that operators started being more and more interested in active share initiatives, which could yield up to 45% savings over a 20-year period. That's a quite big number, and that it could increase even further if we were to consider 3 or 4 operators sharing the infrastructure. Typically, this active sharing can take different forms. The most traditional one lately has been initiatives that have been led by operators themselves. So active RAN sharing, which we see an increasing amount of active RAN share deals in Europe. Examples are Vodafone Orange in Spain, which extended their RAN share deals in Spain. Vodafone Team in Italy that created an active and passive common grid across the country. Or roaming deals. We have in mind, for instance, the New Deal initiatives in France, where in white areas, each operator deploy in different areas, and they roam on each other, thus reducing the total cost of ownership of deploying these areas. However, there is also a third option, which is the neutral host opportunities, which this option creates opportunities that could be harvested by financial investors or also strategic players as well. The neutral host could provide quite few interesting advantages compared to more operator-led initiatives, right? Which just provide an example. In some markets, we see some new entrants. Clearly, in the presence of a new entrant, neutral host can provide a very good platform for the new entrants. Or in some markets, it's not possible to obtain some parity sharing agreements, right? So better balance agreement between operators. So I give you access to a certain footprint, you give me access to an equivalent amount of footprint. That's not always possible, right? So which clearly create tension and negotiation difficulties between operators. Neutral hosts can solve that. Moreover, operators might not have the same kind of commercial positioning or priorities in the CapEx spend. And again, a neutral business model can help operators differentiate their service offering in rural areas to pay and to spend. So you can understand why this is actually quite important in rural areas. I mentioned different neutral host models. In reality, there is not. This is a generic word, which means that the neutral host can take different forms. And we may identify 4 different families of neutral hosts, which I will talk you through shortly. They differ mostly in terms of what are the assets that are included in their perimeter of operations. I'm talking about, just to be clear, about the equipment that goes on the mobile side, which is the real estate, the mast, the tower, energy equipment like connectivity to the grid, generators, solar panels, batteries, and rectifiers, the backhaul, which could be for microwaves or fiber backhaul. Then there is the active electronics, so the base stations, which include the baseband unit and the remote ready unit, antennas, and potentially spectrum. So the most traditional neutral loss model, of course, is the one of the tower co, which normally focus on the land and on the mast, and dependence on the market also could also include the energy within the perimeter. We see then a new type of tower co, which we internally in Analysys Mason call it enhanced tower co, where to extend their business operations to more and more to backhaul, but antennas, especially passive antennas, and also a part of the base station, in particular the hardware component. I will talk then in the next slide about how this is linked to the way virtualization of the networks and the way radio access network architecture will evolve in the next few years. However, we have also very different business models, like the one of the active wholesaler, that does not necessarily have to own the passive infrastructure. So actually that could be a customer almost of the tower co, and the focus is more on the backhaul and on the electronics part of the equipment that go on the sites, as well as the antenna and potentially the spectrum. Right. Some examples are, for instance, Altan Redis in Mexico, the potential Wuhan in South Africa. Finally, we have the most extreme, let's put it this way, type of niche loss, which is really the netco, which really is almost vertically integrated in terms of the technology stack at the mobile sites. All these business models are different pros and cons. And really, the investor need to really understand what is more appropriate for each type of area and each type of market. In particular, in terms of need to understand what is the appetite of the operators to release more and more control of the network, right? Because from going from the left to right, you have a trade-off between control over the network and operating cost. And different operator can be in a different position nowadays, a position that could be different in 5 years. So we need to take a view on what's going to be the future evolution of the appetite of operator towards neutral loss. I mentioned earlier that the radio access network architecture is evolving. It's not staying still. Some of my research colleagues have talked extensively in the summit, but also in the past few years, I would say, about network virtualization, right? I want to better understand, better make you understand how the neutral loss fits within the virtualization. Also repeating a little bit, explaining again what this is about. I mentioned that at the mobile site, you have the base station, which is the active electronics. That is an important component of the mobile access network. That base station is getting decoupled between its hardware component and software component. Nowadays, they are single proprietary equipment that embeds both of them, that is provided by traditional vendors like Huawei, ZTE, Ericsson, Nokia, and so on. The run of tomorrow, actually we see this decoupling with the hardware that can be run on generic x86 Intel architecture, new architectures that are being developed specifically for telecoms, like the one that Qualcomm is pushing forward. Plus then software that can be selected and run separately and owned by the mobile operators, so they can still differentiate in terms of service, in terms of the solutions they adopt, and that can be run more centrally, right, in an edge data center or in a data centers back in the hierarchy of the network. The idea is, of course, to have multiple MNOs reusing the hardware part of the network, which will further reduce the total cost of ownership of deployment on managing the networks in rural areas. And of course, neutral hosts will be happy to incur some additional capex and recharge that capex through fees to the operators. Traditional neutral hosts like TowerCos therefore can benefit from this trend by expanding the perimeter and experiment this new also business model, new relationship with the operator. We expect the appetite for this evolution to be mainly for this kind of solution from the operator to be mainly in rural areas, especially the new remote areas for new deployment, because this is where operators did not want to go by themselves with their commercial initiatives, and also therefore where there is less traffic, and therefore also where operators are more likely to be willing to experiment. Right? In this picture also we could all mention Open Run, which I have not mentioned so far, but clearly Open Run fits also well in this picture, and which could create opportunity to further reduce the total cost of ownership of remote networks for mobile operators, and also create opportunities for investors. Getting to the conclusion of basically this session, we want to highlight what are the main takeaways. Clearly, there are a big frenzy around investments in the traditional three main asset classes in the infrastructure space, which are towers, data centers, and fiber. And there are many investors that tried but were not necessarily able to play a role in the infrastructure space because of different positioning in the capital markets. Rural connectivity, new business model, however, will offer new opportunities for investors that have not been able to play a role but are willing to play a role in the infrastructure space, and which could be particularly important nowadays in a pandemic and a COVID-19 environment, given that we see many financial investors be interested in including digital assets in their portfolios, given that many industries are struggling, whereas the digital space is actually showing very positive trends and appetite, both in terms of consumer demand, but also from investment from investors. The second key takeaways that we want you to take home are the fact that strategic investors that play a big role in the infrastructure space so far, fibercos, towercos, and data centers in the first place, cannot really sit on their past success and needs to continue innovating, experiment new business models if they want to continue growing, right? So they need to actively listen to the customers, to the fixed and mobile operators, and experiment with them in order to be ready when these new opportunities arise, in order to harvest them in due time. Finally, the third takeaway that we want to highlight is that it's not just about infrastructure. It's not about infrastructure investment. Rural connectivity creates benefits for many different types of investments because there is an expanding ecosystem, which therefore that requires funding to grow. Right? This expanding ecosystem includes also FWA players that were covered by Richard, hybrid operators, private networks, specialized neutral hosts that I was discussing earlier, but also vendors of hardware and software and other vendors that are active across both the fiber and the mobile deployment value chain. I think that that's it in terms of our presentation. I hope there is still time for Q&A. I will hand over to Natalie.
Okay, thank you very much, Richard and Alessandro. So yes, we'll now go over to the Q&A session. If you want to ask a question, please submit your questions in the box on your screen or navigate to the Q&A widget. Now, we have got some questions that have already come in during the presentation. So let me just scroll down. Okay, so the first one, what impact has COVID-19 had on deployment of rural infrastructure? Has this slowed down investment and network rollout?
I could take this one. So we've had this discussion with a number of operators and investors over the last few months. I mean, there's been a clear impact of COVID-19 that, if anything, it's accelerated the growing demand for high-speed broadband and more reliable broadband in particular. From the operators we've spoken to, there has been a negative impact of lockdown in some areas. There was often a slowdown in sales where, of course, you couldn't carry on with door-to-door sales, which have been a big part of the approach for some of the rural-focused operators. And also, in some cases, slowing down customer installs, which required engineer visits. That being said, this was what seems to be a relatively temporary slowdown, and we haven't seen much impact on the pace of overall rollout of fibre infrastructure or FWA networks. Generally, telecoms workers have been designated as essential workers, and the rollout work has continued. And we've certainly not seen any slowdown in transactions, both in the fibre and FWA space. Investors seem to be comfortable that the demand for high-speed broadband is there, and we're seeing lots of continued interest.
Okay.
And if I may add, we see a similar picture also across mobile infrastructure space with COVID that clearly had an impact on the traffic patterns and the congesting areas of the networks that were not necessarily congested before, and therefore driving more demand for densification or coverage extension from mobile operators. So there is a relatively rosy picture, let's put it this way, when it comes to demand for infrastructure, which has a ripple-on effect on the funding requirements and therefore opportunity for investors.
Okay, thank you. So next question. What is the timing of the neutral host opportunity, and when should we expect it to become mainstream investment trend?
This is a good question. Worth noting that there are already today some investment opportunities in the, let's call it, neutral host space. Of course, I assume that the question is about the less traditional neutral host business model, because we see a lot of demand on the tower co space still, and we expect this to continue. I think it's worth noting that that there are already, therefore, opportunity today, especially in certain niche areas, right? The rural areas, of course, an extension of nature rural areas is clearly one of them, but it's not just it, right? So you could have neutral hosts also to support potentially in increasing demand for indoor connectivities to manage therefore indoor small cell or DAS. And these are opportunities that are very, very, very much live today. Clearly, if we're talking about a big wave of investment in the, on neutral host, it's something that we recommend investors to start already getting ready shortly, because I'm not saying that it's going to be the demand maybe in the next 1 to 3 years. The mainstream demand may take place in 4 to 5 years plus. However, it's already the time to start experiment, to be ready when opportunity arise. And that's even more important, I think, for existing strategic players, as I was suggesting earlier, they need to start to experiment in order to ensure that they play a central role on new opportunities as they don't get marginalized in the future.
Okay, thank you, Alessandro. I think this may have to be the last question due to time. So who will be best placed to play the neutral host role? Do you expect this to be existing or new players?
That links a little bit to the answer I was just providing especially on tower costs, right? But and tower costs that need to experiment, continue evolving their business model in order to play a central role in the infrastructure space in the future. So the jury is out there in reality. So definitely there's going to be a big role for the strategic infracos that are bold enough to play a role in that already, start experimenting. However, there are also opportunities for small niche providers that develop themselves around specific use cases that have been maybe disregarded by more mainstream investors or mainstream infracos nowadays. And from a niche, you can grow and maybe internationalize and become something more and more important.
Okay, thank you. Well, unfortunately, we have come to the end of our time. Thank you very much to the presenters. If we didn't answer your question, the presenters will get back to you soon. I just want to say thank you very much for attending the Analysys Mason Telecom Summit. All day 1 and day 2 sessions will be available for you to watch on demand later today and will be available on the platform via your login for several months. If you have any questions, please do contact us via the contact link at the top of the event homepage or via the request an analyst speaker briefing. Thank you very much for joining.